Hi, Larry Stewart here with ForConstructionPros.com. Welcome to Caterpillar's Tanaha Hills Demonstration and Proving Ground. Meet Jag Samaraweera. He's the Commercial Support Manager for Caterpillar's Command for Hauling Systems with CAT Mining. Thanks so much for being with us.
Glad to be here.
Caterpillar has a lot of experience with autonomous machines. We started hearing about Command for Hauling, what, in the 90s, late 90s?
Yeah, it actually dates back to the late 80s when we were testing on GPS, right? Just to see how the global positioning system works with our base machine or mechanical drive trucks. And then we actually showcased a couple of autonomous trucks back in the, I think, mid-90s at a construction or quarry site to make sure it was somewhat viable. And we realized it was, but at that time, the cost was too much for it to be commercial. And then we got into the DARPA challenges with the US government, and then from there our program just took off. And we actually launched a commercial product in Western Australia in 2013. Wow. And that was about 6 trucks, and now we're over 500 trucks.
Wow.
And we've traveled about 145 million kilometers, roughly 90 million miles with 0 lost time injuries. So it's a great example of the success of the program.
The production there numbers are pretty significant too. There's a lot of material hauled because we're talking about big trucks here.
So they range from about 150 tons all the way to about 400 short tons as well.
Yeah.
And we moved about 4 billion tons in the last about 8-9 years.
What kinds of things has Caterpillar learned about reliability of these systems in that period of time?
So a lot of the components when you first start were commercial grade. And as Caterpillar, we harden things, right? Our machines are robust, especially in mining, running 24/7. So we took that experience we had and then hardened some of the components to run in a mining environment. So that's one of the critical things that we brought to the program over the years.
Running 24/7 is a real significant part of the return on investment in this technology for these mines, right? You're running around the clock.
Yeah, it's the consistency that automation brings, right? Because on a normal routine, you know, as human beings, we're not consistent. But with Command for Hauling, with the MineStar system is every operator, and we're very consistent, right? So we have that productivity that compounds over time.
The interesting thing for ForConstructionPros.com readers is, you know, we're largely a construction book, and so I'm thinking about the crossover here to construction. So we're seeing here at the CAT Trials demonstration, actually pre-market version of Autonomy on a compact track loader. And the first questions that come to mind for me, and I think for a lot of folks, is, you know, how much of that experience with reliability and safety with autonomy is going to translate over to construction sites?
When you look at the technology, that's all 100% translatable to construction. Whether you're doing road construction or commercial development, especially large earthwork projects. But it's trying to bring it down to what is more dynamic in nature. Like you hit a great point when you're saying it's regulated, right? Mining is heavily regulated. And if you look at automation in the mining environment compared to what you see in the commercial environment, like on like Waymo or Tesla, they're doing a lot of their testing in the public area, but we are highly regulated. So to bring that is the next step, I think. But the technology, even when you look at all of our trucks, it's pretty much identical. It's just downscaling it to a smaller truck.
What we're seeing on the CTLs here, as I understand it, is not the same hardware. It's the same type of hardware, but by a maker of much smaller systems.
And the good thing about starting with mining is that we figured out the technology, we made it robust. Now we're going to take some of the automotive technology and kind of swap some of those components, which makes sense for a construction type customer.
And, you know, really kind of get started thinking about repetitive applications. Because I know this CTL application, the sort of the first one that they're working on, is a very controlled environment,
That's
a big
right.
solar farm, you know, where CTLs are traveling miles every day, just bringing materials out to where guys are installing them. To me, an interesting starting point to start thinking about, okay, you know, haul roads for mass excavation, you know, sites where there's a lot of space.
Exactly. I think the dynamic nature is the next challenging part that we have to overcome.
Which is not to say that the LiDAR and the cameras on the mine systems today aren't able to deal with that. They can detect the difference between a pickup truck and a human being and a cone and a rock and adapt to that circumstance. Really, it's about the algorithms, right? About how to respond to them.
Exactly. So in a mining site, you got to be trained to enter an autonomous operating zone. But in a construction site, you may have something similar where you don't have as many people. So that may abate some of the development that needs to be done to handle that dynamic nature.
The software that supports how the machine makes its decisions to respond to the movement around it is I would think a frontier where you've learned a lot in the mining industry.
That's where LiDAR comes into place. It's based on LiDAR and radar. They work together, and we've fine-tuned that over the years. We're actually using machine learning to improve that. When I was doing validation, we would stop for dust about 200 times a day.
Oh, wow.
That is not something that's consistent and productive, right?
Yeah.
Now our trucks can kind of manage the dust and not slow down and kind of drive through it as well.
Yeah.
And we've trained that over the years. And we run in snow, fog, rain, so we've trained with machine learning the system to adapt.
Weather can really influence, what that LiDAR and radar sees.
One of our customers in the oil sands, I actually went out there looking at the site, and one of the things we had to notice was the snow, right? The ice, the soft underfoot conditions. And we actually designed the system to work in those conditions. And that was about 2017 when he kicked off that project. And they're running, I think, a fleet of trucks now, and they're going to continue to expand.
The systems are replacing operators in the trucks. How's the staffing changing on mine sites that are using autonomy heavily?
So what we always say is people, process, and technology. Even among our customers, the technology is the same. Right? Productivity is a bit different, but it goes back to the people and the processes. And what happens, some of the operators end up being the best operators of our system because they know the field, the conditions, the environment, and how to operate the system as efficiently as possible. Compared to when I first started as an engineer, I didn't know much about mining at that time, but over the time of being at a mine site, I found out the operators are excellent users of the system.
Operators aren't going away, they're able to be more productive. It's not one operator per machine anymore, I'm assuming.
They're just watching over the fleet and the functionality of the system.
Which matches up well to a dearth of human hands to put into seats. In terms of development and refinement of these systems, what areas of the mines are you working on most?
So we're covering pretty much all the basic materials. We're in iron ore, coal, copper, and oil sands. I mean, we're going into deep pit mining is our next challenge that we're ready to take on.
I see. And how is that different from the applications that you have now in terms of autonomy?
So when you get deep pit, everything, you have to have your position. That's one of the systems we have. It's based on GPS. In a deep pit mine, you could come across high walls which restrict the GPS signal. So we have to augment probably almost a ground-based positioning system.
And that also has a direct application to construction sites because there's so many sites out there that have difficulty with wireless networks. So I imagine you're going to develop systems for bringing base stations in that'll you'll learn a lot of things on how to get that connectivity into
exactly
remote areas. We talked a little about evolution of the technology. Any significant advances that you could say, in the 90s or the early 2000s, we were having a little difficulty with X, we've gotten better at that?
I think the biggest change is technology itself. Before, it's very mechanical base driven. And if you look at the buttons back in the mid 90s, they're big red buttons. You call the truck, you hit the button, and I've seen footage of it in the Caterpillar archives, but I've never seen it. But you see the loader operator hit the big red button and the truck backs up. Now everything's electro-hydraulic, and it's at the fingertips of the operator, and they just hit the button, the truck comes in.
I really appreciate your help, Jag. I wish you the best of luck with this tech, and it's really cool seeing it out here in the fun trial setting that Caterpillar set up for us.
Thanks for coming out, Larry.
Thanks.
Yeah. There's a war going on inside. Just to name a couple, I battle with porn and pride and a persistent